Hi everybody. So this is going to be a hopefully quick video in which we discuss basically how evolution works and what it gives us. Okay, so I'm going to share my screen with you. All right. So in another video I mentioned classic fitness, and what I mean by classic fitness is simply what we mean by fitness in evolutionary terms in the classic sense. So there's a classic type of fitness, because since the 70s we've had a second type of fitness known as inclusive fitness. So we're going to first talk about what we classically meant by fitness and what we mean by inclusive fitness. Okay, so classic fitness, the traditional term of fitness in evolutionary biology, is simply how reproductively successful an organism is. All right, now that doesn't just mean having babies. All right, that means having offspring and getting them to reproductive age. All right, so organisms that are high investing, like us, all right, humans are one of the highest investing species on the planet. And what I mean by investing is we put a lot of time, energy, and effort into our offspring and raising them. All right, on average, we spend a lot of time trying to not only have children, but raising them up. When we raise them up, we're raising them to reproductive age, getting them to a point where they are capable of reproducing. And so having offspring is not good enough. It's having offspring and getting them to reproductive age. Now, a lot of animals, in fact, probably most animals on the planet, don't have to wait very long, and certainly not as long as humans have to get their offspring to reproductive age. All right, you know, we don't become reproductively viable until we're about 10 years or a little bit more. All right, after we're born. Whereas other animals, they become reproductively viable within the first year. All right, sometimes not much into that first year. All right, some animals, such as insects, become reproductively viable almost immediately. So classic fitness refers to reproductive success. How successful is the organism at reproducing and producing viable offspring? Now, another piece of that viable piece is they have to be, and it goes back to them being reproductively capable. Some organisms are still relatively close in their evolutionary history to one another. So they might be different species, but they're still close enough that they can reproduce. Lions and tigers, they're still close enough in their evolutionary history that they can reproduce. Donkeys and horses, they are still close enough in their evolutionary history that they can reproduce. However, when a lion and a tiger reproduce, they don't reproduce a viable offspring. Lions and ligers are impotent. They are incapable of reproducing. Mules, the products of donkeys and horses, are impotent. They're incapable of reproducing. All right. So it's not just about having offspring. It's about having offspring that are then reproductively viable. That's what defines an organism as fit. All right. Now, this second type of fitness is inclusive fitness. And inclusive fitness applies to all organisms, but it certainly is thought to be more effectual, more effective, more influential in social animals like us. All right, inclusive fitness refers to our ability not only to reproduce ourselves, but also to facilitate the reproduction of our genetic kin. All right, so if we are able to facilitate our brothers and sisters, our cousins, offspring, if we're able to help them reproduce and then help those children get to reproductive age, and again, this is not just humans, this is every animal on the planet. If we're able to get those organisms, those offspring up to reproductive age, then that also improves our inclusive fitness. Basically, the traits we have are going to have a greater chance of moving into the next generation when those who are related to us, who also presumably have many of our same traits, are able to reproduce. So inclusive fitness is our fitness plus the fitness of our kin, but that the fitness of our kin adds to our inclusive fitness to the degree that we're related. So our brother or our sister having a child adds to our inclusive fitness more than our cousin having a child, because our brother or sister shares, I believe, 50% of our genetic makeup. Our cousins don't share that much. I believe theirs is closer to 10%, but I don't exactly remember. All right, but because because our cousins share less of the genetic makeup with us, their offspring is going to improve our genetic fitness, our inclusive fitness, less than our brother or sister having a child. And our cousin will improve our inclusive fitness even more than a second cousin or a third cousin or someone who isn't related to us. All right. So the less and less they're related to us, the less them having a child, the less them having an offspring that's capable of reproducing affects our inclusive fitness. Now, inclusive fitness has been thought to be one of the evolutionary drivers for a lot of pro-social behaviors. So we'll talk about pro-social behavior later in the class. Inclusive fitness is thought to be one of the reasons we engage in pro-social behavior. And I'll mention this later in another video, I'm sure. But in general, for the majority of our history of a species, we ran around in small groups of genetically related individuals. And so as a species, we developed these mechanisms to identify those who are genetically related to us by looking at them. All right, because up until very recently, we had no way of knowing whether each other was genetically related to us. And so we had a couple ways that were tuned to look into to assess whether or not someone is related to us. One is similarity. Do they look like us? Second is witnessing parental care. Did we witness our parents taking care of them? All right, but we'll come back to that in a later video. Okay, so those are your two kinds of fitness. Classic fitness, which is all about an individual's ability to reproduce and get their offspring to reproductive age. Inclusive fitness is about our own plus our genetic kin's ability to reproduce and get their children to reproductive age. Now, all forms of evolution, whether it be by artificial selection, natural selection, sexual selection, all of them work by this mechanism, by the mechanism of fitness. So when you hear the expression survival of the fittest, we do not mean the strongest, the smartest. We don't mean those things at all right? We mean the survival of those capable of reproducing most successfully and getting their children to reproductive age, all right? Now, what does evolution give us? Because oftentimes people assume that evolution only gives us adaptations, but that's not true, all right? Certainly, adaptations are one of the products of evolution. So what is an adaptation? An adaptation is a trait that helped our ancestors overcome some obstacle. We call those obstacles selection pressures, okay? So when, let's say that there was a selection pressure of needing hydration, and this would have been far, far, far back in our history, not as a species, it would be our predecessor's history. We have a problem of hydration. We need to keep moisture in our bodies. Most animals on the planet are primarily water, all right? And it's thought that that's largely because life on this planet began in water. So we basically just took small microcosms of water with us. We evolved to take the water with us. And so our bodies are primarily water, all right, fluids. Now, if that fluid gets depleted, we die, right? So the adaptation of thirst develops to address that problem. Organisms, when thirst was first showing up, right, a mutation showed up that caused organisms to go get water when their hydration was diminishing. Those organisms survived longer than those who were not compelled to go get water when they were low on moisture or fluids. So thirst is an adaptation. that addresses the obstacle of maintaining a certain amount of moisture or fluid in the body. Okay? But not everything that we do, that we have, is an adaptation. Some things are byproducts. All right? So byproducts are traits that co-occur with adaptations, but don't actually do anything beneficial on their own. All right. So in his book, The Descent of Madness, one author argues that schizophrenia is a byproduct of the social brain. Okay. The evolution of the social brain. So here we have, a quality, schizophrenia. So some people students in my prior classes have asked, well, why would have mental disorders evolved? Well, again, not everything is an adaptation. Some things are byproducts. All right. Well, schizophrenia, as the author of The Descent of Madness suggests, may be a byproduct of the evolution of the social brain. Other mental disorders, not handicaps, mental disorders could be byproducts of certain features of the normal human brain as well. All right, and it may not just be mental disorders. All right, an example that Buss constantly uses in his textbooks is the example of belly buttons. Specifically, the adaptation is the umbilical cord. It addresses the obstacle of getting nutrients to the offspring who's internally gestating. All right, the mother can ingest something, and then the umbilical cord takes the nutrients, proteins, everything that the offspring needs to develop to the offspring. But then a byproduct of that is our belly buttons. All right, because once we're born, that gets cut off or it gets severed, and then we have the creation of a belly button. All right. Now, we also have, sorry, my puppy was looking like he was about to be sick. Anyway, so we have byproducts, and byproducts are in no way adaptations. They just kind of piggybacked an adaptation. They are in some way tied to the genetic program that produces the adaptation, but they don't actually provide any kind of benefit whatsoever in themselves. The third product of evolution is noise. All right. If you go back and watch my video over the principles of natural selection, and recall the very first principle, which is variation, you will see why noise can pop up. All right. Noise is just, because remember, we all vary in genetic mutations, we all vary in traits. Any of those, if we had a trait, right, that allowed us to do something, if it just popped up because of random variation, it's noise. It's not an adaptation. Now, noise and byproducts develop not because they address an obstacle, a selection pressure, as we mentioned earlier. Only adaptations develop for that reason. But byproducts and noise, if they end up being beneficial, if they end up helping address some selection pressure over many generations, they can become adaptations. But most adaptations aren't adaptations at first. All right, they're noise, or the product or byproducts, or the product of random variation, which again, noise, right? So back to that example Buss likes to use in his textbooks. The umbilical cord is the adaptation. Having a belly button is the byproduct. All right, it goes with having an umbilical cord, even though it doesn't have any benefit of its own. And the shape of your belly button, like any Audi, all right, that's noise. It has nothing to do with either one. It has no benefit of its own. All right, it's just natural variation. Okay. Again, byproducts and noise can become adaptations over many generations, but they don't start that way. Okay. And it's the process of studying evolutionary biology by which we identify what traits are adaptations and which are not. All right. All right, guys, that's it for this video. talking about the products of evolution and the fundamental mechanism that drives all evolution, artificial, natural, or sexual, and that's differential reproduction. All right, guys, as always, if you have any questions, let me know. If not, have a great one. I'll see you next time.